Alrighty, number 6. This is another factoring problem. Got a lot of these. See a pattern? Okay, but this one looks weird. You guys are not used to seeing fractions as exponents, but this is actually no big deal. Don't let it psych you out. As long as the exponent of the first term is exactly 2 times the exponent of the second term, then this is pretty much just a regular factoring problem that you've done 100 times over. 2/9 is exactly twice 1/9. So what we do is this process called substitution. We can pick any letter that we want to. I just use u most of the time, and I say that u is equal to x to the 1/9 power. And what that allows me to do is I get to write this trinomial as though it's just a regular trinomial. I got 96 u squared, because u times u, if it's x to the 1/9, x to the 1/9 times itself is x to the 2/9, okay? Plus 108 u, because that's x to the 1/9, plus 21. Okay, now from here, I'm just going to factor all of this the way I would normally factor it, and at the very end of the problem, I can just bring my x's back. Okay, so the first thing you always want to do in your factoring is check for a greatest common factor. If you start by just multiplying 96 by 21, not only are you going to have enormous numbers, you're also going to miss out on one of your factors. When it says factor completely, we have to have all of them. Okay, so the greatest common factor in this case is going to be 3. I can divide all of these by 3. And if I do divide them by 3, that's going to be 96 divided by 3 is 32. So this would be 32u squared. 108 divided by 3 is going to be 36u. And then 21 divided by 3 is just 7. So yeah, our numbers are still going to be big, but they're not going to be quite as big. So this a is greater than 1 problem, just like we did on, what was it, number 3, we're going to have to start this by multiplying the a value to the c value. Okay, so I'm going to consider that separately, just over here, and work it out over here. So u squared plus 36u plus 32 times 7 is 224. I'm going to factor this into 2 binomials. U times u is u squared. I see that the signs are going to be the same because it's multiplying to a positive number, and they're both going to be positive because they're going to add to a positive number as well. The numbers that multiply together to make 224, there are a lot of them, but we only have to go far enough to see what adds together to make 36. So we've got 1 times 224, definitely doesn't add to 36. 2 times 112, we're getting closer. 4 times 56, 6 doesn't go in because it's not divisible by 3. 7 does go in. 7 goes into 22 3 times with 1 left over and goes into 14 twice. 8 does go in because 8 goes into 22 twice with 6 left over and goes into 64 8 times. And there's probably a lot more combinations, but this is the one we're looking for. 8 plus 28 is 36. So 8 and 28. And now this is the factored form of this trinomial. To make it the factored form of this green trinomial over here, we've got to divide by the a value, the 32. So we divide by 32 over here. We're going to simplify both of these fractions. 8 and 32 have a common factor of 8. So if I divide the top and the bottom by 8, I get 1/4. And 28 and 32 are both divisible by 4. If I divide the top and the bottom by 4, I get 7/8. And then now that these fractions don't simplify, we put the denominators in front of the u. So we're all the way back over here at 3 times 4u plus 1. And then 8u plus 7. And you'll be tempted to end the problem right here, but the problem's not done until we bring back our x's. Remember these weird fractional exponents. So 3 is going to stay there. 4 times x to the 1/9 power, because that's what u is equal to, plus 1. And then 8 times x to the 1/9 power plus 7. and this is the factored form. We could write these as square root of 9, but that's just an extra step and it's not necessary. Anyway, that's number 6. Thanks for watching.